welcome back to my channel. Hope you guys doing good. Today we are tackling important bulb related questions that appear frequently in exams like GATE, SSC, JEE and RRB JEE. Bulb problems may look simple, but they actually test your understanding of concepts like resistance, power rating, voltage and circuit behavior. So, if you ever wondered why a 100-watt bulb glows brighter than a 60-watt bulb, or how bulbs behave in series and parallel connections, then this video is for you. Let's dive in and start solving step by step. Keep these equations in mind. V is equal to Vi equal to V square by R equal to I square R. These are the basic equations that we are using to solve bulb related questions. So make a note of these equations, and this all are simple and that we have known from the basic classes. Now let's dive into the questions and solve them one by one.
Now let's have a look at this question. Here we are given a 100-watt bulb to 100-watt to 20-watt bulb connected to a 220-watt supply. We are asked to calculate the resistance of the filament. We know that P is equal to V square by R. And to find out R, what do you have to do? V square by P. Here V is 220 volt, 220 square, and V and P is 100. So what we get? 484. That is 22 into 22, 4444, that is 484 ohm. Simple, just we have to know this formula and we can find this question. This is a basic question, so this is the easiest one to solve. We will have a look onto more ones. Comes the next question, which is somewhat similar to the previous one we have done. The difference here is that we are using two bulbs connected in series and we are asked to find the total current. So this is the difference here. If we know the simple equation to find the current is V by R, which is something we derived from Ohm's law. So here we know what is V, which is 220 volt, and we need to find R. To find R, we can use the same equation we used for the last question, the power equation, V squared by R. So here R will be 220 square by 100, which is 484 ohm. By the way, we have to make sure that this is a resistance of one bulb. This is a resistance of one bulb. How many bulbs do we have here? Two. So to find the total resistance which are connected in series, which is R1 plus R2. Since these bulbs have the same resistance or same bulbs, we can write 2R will be 968 ohm. And from here, what we need to find? We need to find the current. So current will be 220 by 968, which will be equal to 0.227 ampere. If you use a calculator, you will just get the same answer. So this is how we will find the current. If we have of a bulb, if you're given just the ratings and the voltage. First find the resistance, then find the total resistance. If it is more than 1, if there is a 3, if instead of 2 bulbs, if showing 3 bulbs, what we'll do, our total will be equal to 3R. If is the ratings are same, if there are different bulbs with the different power ratings, then we will do this equation, we won't use this. But here the value of the resistance is same because same rated bulbs are used. You have to keep that in your mind. That's it. We'll go to next question. Next question here is two incandescent bulbs of rating to 30 watt to 100 watt to 30 watt to 100 watt are connected in series. So the fact you have to think about is the same voltage ratings, same voltage rating, and they are connected in series. The question here is to find which one of the bulb will glow brighter. We have got two bulbs and which among them will glow brighter. How will we find that? Let's find the resistance of each bulb. So resistance of the first bulb, resistance of the bulb with 100 watt power. Which equation we are going to use? We are going to use the power equation V square by R. So V square by P. Here V square is 230 square by P 100, which is equal to 529 ohm. Now let's find the resistance of the second bulb. 230 square by 200, which is equal to 264.5 ohm. We have only got the resistance. We need to find which of them will glow brighter. We know we have another equation for the power. P is equal to I square R. We have been told that this is a series circuit. For series circuit, the current I will be constant. For a series circuit, current will be constant. So we can say that the power consumed is directly proportional to R square, my bad. Directly proportional to R since the current is constant. What will be the conclusion here? Power consumed is directly proportional to the resistance. So if resistance increases, power consumption also increases, which results in the bulb glowing brighter. So which among the two bulbs has higher resistance? The first bulb. This bulb has higher resistance, hence the power consumption will be higher resistance, then the power consumption will be higher, then and it will glow brighter. So the first option is correct. 100-watt bulb will glow brighter. But this takes a lot of steps to come to this conclusion, right? But when we are doing it in an exam point of view, where we have a lot of questions to complete in a minimum time, doing all this will consume a lot of your time. So I will tell you a secret how to do it. And the condition here is, this is the, if the bulbs have same voltage rating, so if we have given a question with bulbs having same voltage rating, then the bulb with lower wattage will glow brighter. So what is the conclusion we are getting, or what is the trick? When you're given two or more bulbs with the same voltage rating, here this is voltage rating is same, 230 volt. If it is given the same voltage rating, then the bulb with a lower wattage will be glowing brighter. In a series connection, it will only happens in a series connection. For a parallel connection, it is different. For a series connection, if the voltage rating is same, then the bulb with lower wattage will be glowing brighter. Take an example. If you have given 3 bulbs, okay, if you are given 3 bulbs, one of the same voltage rating, but the power rating is different. For example, this is 100, this is 250, and this is 60, and all of this are connected in series. And you are asked the question, which one will be glowing brighter? Which, just looking at the bulb ratings, we have to find out the conclusion that the one with the lower wattage will be glowing brighter. If there is one more, for example, this is 160 and this is 80, all of them connected in series, which one will go brighter? This one. I'll give you another 3 examples. So we got, okay, same voltage rating. Consider 4 bulbs. This is 110, this is 150, this is 100, this is 250. Which one? And all of them connected in series. So this is a condition, this is a condition. Which one will glow brighter? This one, the third bulb, one with the lower wattage, will be glowing brighter. So keep that in mind. If one or more bulbs connected in series with the same voltage rating, then the one with the lower voltage will be glowing brighter. So when it comes to parallel, it's different, and we will discuss that in the next question. The questions with the same question with a parallel connection. So we have to find which one will be glowing brighter. We know from the previous question that the resistance of the 100-watt bulb is 529 ohm, and for the 200-watt bulb is 264.5 ohm. This one has a larger resistance than this one. So this is a parallel connection. In parallel connection, what is constant? Voltage. Since voltage is constant, we can use the equation P is equal to V square by R, P directly proportional to 1 by R. So lower the resistance, higher will be the voltage. Which one have a lower resistance? The second bulb have a lower resistance. So the one with lower resistance will have higher power consumption, hence that will be glowing brighter. Then this one will go brighter. So the answer is B. Next question is another one where it is shown that two electric bulbs having filaments of the same metal and having the same thickness. If one of them gives 100 watt, another gives 500 watt across the same supply, then which one of them is shorter, longer? This is to find out the length. Which one is longer or shorter filament? Which bulb have a longer or shorter filament? That is what we have to find out here. So it is something related to the length. What have we have? We have this saying the same metal and same thickness and same supply. So all we know it is when it comes to questions like bulbs, with all the stuff, we go to the basic equation P is equal to V square by R. Okay, take this here. And we also know this. What is an equation that relates resistance and length? It is rho L by A. This is the equation that relates resistance to length. We have been told that they have the same thickness and the same metal. From here now we know this rho, it is a it is a material property. It is a material property. Each material has its own different rho values. Since the same metal is used, the rho value for 100 watt and 500 watt will be same. So rho will be same in both the cases. And since thickness is also same, then area will be also same. So R is directly depending on resistance. If the resistance increases, length will also be increased. So the longer the length, the higher the resistance. What conclusion we are get? Longer the length, higher resistance. This is not a general fact. This is not I'm not stating a general fact. This is specific to this question. Since we have the same metal and same thickness, we can say that longer the length, higher will be the resistance. And we have to find the resistance. We'll rearrange this equation. R is equal to V square by P. It has been told it's the same supply. So for both the bulbs, the supply is same. V square will be same. So let it be like that. V square by 100 and V square by 500. We know that if the higher value is on the denominator, then the answer will be less. From here we can conclude that R100 is greater than R500 because this one holds higher value at the denominator and it will be slow, and the original value will be less. So R100 is greater than R500. So R100, the resistance of the 100 watt bulb is high and hence will have a longer length. So answer B is correct. So whenever you get confused with all this question, we have to think of the equations that relates to whatever we have in the question. So here it is about length. Then think about the equations we know about power, voltage, resistance, length, and then you'll get into these two equations. Use your ideas and then you will find the answer. That's it. section we discussed a few bulb related questions, and the basic of all question is to know the bulb equations or the power equations which relates power, current and resistance and voltage. So if you have an idea about these two equations, and it is quite easy to solve most of the bulb related equations. And please remember the shortcuts we have discussed earlier to quickly answer the questions in exam point of view. I hope you have understood what I have been discussed in this section, and if you have any doubt regarding to whatever we have discussed, please do leave a comment, and if you I will try to solve as much as I can. And thank you for listening to me, and we will be coming in with more questions and we'll be discussing new topics every day. Thank you so much for watching.
Remember, always start with power and voltage, then derive the resistance. Practice makes steps, and you will breeze through the questions. That wraps it up. Practice these formulas and question structures regularly. If you found this helpful, subscribe and keep your concepts shining bright. Thank you.